Joey Palmowski. I'm a systems engineer at Honeybee Robotics, and I'm going to briefly acknowledge some of the technology that we're working on to address the needs of lunar sustainability and advancing these objectives of the Artemis Base Camp. I'm going to discuss Rebel's coiled tubing drill for deep subsurface access on the moon, the Redwater coiled tubing drill for addressing ISRU objectives on Mars, but how that can also be applied in a lunar application, and Lister and Lunar Planet Vac, both payloads on a Eclipse mission flying to the moon later this year. And the fundamental concept behind all these technologies are fairly agnostic as to whether they're addressing science or ISRU objectives. Next slide, please. The Rebel system derives from Honeybee's coiled tubing and pneumatic drilling technology, and this enables deep subsurface access. The architecture consists of coiled tubing, a storage drum for the coiled tubing, an injector mechanism, a bottom hole assembly, which includes a rotary percussive drill at the tip, a sample collection head for collecting regolith at the surface that is pneumatically ejected from the borehole, and compressed gas storage tank at the surface for supplying the pneumatics for the excavation and sample collection. So right now we're exploring capabilities within 10 meters of subsurface depth, but it's not hard to imagine a version of this system that could penetrate 20 meters or 50 meters or maybe even 100 meters. And this because of the coiled tubing approach that we use. It's not a new concept. It's been around for decades in the oil and gas industry, enabling exploration depths down to surpassing 5 kilometers. So aside from being very effective at enabling deep access with a relatively small footprint at the surface, it also has the advantage of providing continuous use of hardwired electrical power and telemetry using the coiled tubing as a conduit between the bottom hole assembly and the surface. And this allows for directional drilling as well. So
1 minute.
So and then the bottom hole assembly consists of a rotary percussive drill for a vehicle which also can be a vehicle for downhole instruments, offering the advantage of in situ measurements. And we're currently exploring ways to add instruments to that. Near the tip of the drill is where we have outlets for our compressed gas to be released, which will eject the cuttings to the surface. At the surface, Rebels uses a deployable sample collection head to encapsulate the head of the borehole to capture the cuttings coming out. So this is inspired by various high TRL technologies, including the Redwater system previously mentioned, the Lister and Planet Vac payloads, both of which are going to be on Firefly's Blue Ghost Lander Mission 1, currently slated for later this year. So we're very excited for that, and we're hoping we get some key data from that will ultimately support establishing this lunar base camp. Thank you very much.